Okay, so welcome back. Now, here we've got this diagram, and we've got two non-vertical lines, right? And so we've got this angle here, theta 1, with the L1, and we've got theta 2 that's made with this, with the vertical angle with the x-axis with line 1. And so we've also got theta, which is the angle between the two lines L1 and L2. Okay, so now, what we want to show is that tangent theta is equal to m2 minus m1 over 1 plus m1 m2, where m1 is the slope of line 1 and m2 is the slope of line 2. Okay, now, keep in mind, remember that if I look at the slope of a line and I make a right triangle, that the slope of the line is the same as the tangent of the angle, because remember, tangent is opposite over adjacent, rise over run, okay? And then likewise for line 1, we can make that, the slope the same thing. So we can use that information to solve. But before we can do that, there's one other thing that we need to realize, is that if we take this angle minus this angle, that's going to equal theta. Okay, that's going to be important to understand. Now, again, if you don't see it right away, you gotta use geometry. Okay, so I'm going to show you how I looked at this. So notice that we have this triangle here. Okay, notice also you have to remember vertical angles are congruent. So we know this angle and this angle inside the triangle is the same. Also, we know that this angle and this angle are supplementary. So this angle on inside the triangle has to be pi minus this angle. Now also notice that all three angles of an interior triangle, or the interior angles of a triangle, add up to 180 degrees or pi. Okay? So that's what I did. So I said, okay, well, let's take pi minus theta 2 plus theta 1 plus theta, so those are the three angles, the three interior angles. That has to equal pi, right? It has to equal 180 degrees. Well, if you write it out this way, then you can cancel the pi with the pi on either side of the equal sign. And then you end up with this. You end up with theta 1 minus theta 2 plus theta equals 0. And so then I took the theta 2 and added theta to both sides, and I got this. Theta 2 is equal to theta plus theta 1. And then I just subtracted theta 1 from both sides, and I get the result that I want. And this is the result that's going to do it for us. Okay? So that's going to be important. So now what I'm going to do is, to get from here to here, I'm going to use that. And so now I'm going to start by saying, okay, well, tangent theta is equal to tangent of theta 2 minus theta 1. And now this is where it falls apart, because now, as you can see, this looks very similar to the definition of this. So now what I'm going to do is I'm going to put it in there. So this is going to be tangent of theta 2 minus tangent of theta 1 over 1 plus tangent theta 2 times tangent theta 1. Now all I have to do is plug in m1 and m2, because remember, tangent of theta 2 is equal to m2, right, the slope of line 2, and tangent theta 1 is equal to m1, which is the slope of line 1. And so if I do that, then I get m2 minus m1 over 1 minus m2 times m1, or m1 times m2. And that's it. Have a great day.